Welcome back to my channel. Today's episode is a continuation learning about mouthpiece design so we can get to learning about refacing them properly. So I was thinking that looking at a few manufacturers' videos of how they make mouthpieces is important in understanding manufacturing techniques. Now this has changed dramatically over the years. I believe it was about 15 or 20 years ago I saw a video of Selmer Paris of mouthpiece production. What was really interesting is that they used a grinding wheel which make continual passes over it to create the table and facing curve on rubber and metal mouthpieces. For example, let's just say this is the grinding wheel. What would happen is it would start grinding down the face of the facing curve and the table. So grind, 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 back and forth, slowly cutting it down until it got done with what it wanted to do. Then it would eject it, and someone would put another one on it. Of course, the more grinds it does, the more it heats up the material, in this case, rubber. And what would happen many times is you would get the rubber would heat up and expand and then shrink again later on as it cooled. So you get wavering tables, and many times at the end, you would get a little ramp on the end of the mouthpiece. Of course, it changed a lot since then, but that's just one example. But if anyone finds a copy of that old Selmer Paris video of how they made mouthpieces and you see them using a grinding wheel, send me a link of it, please. So we're going to take a quick look at a few videos here. And talking about Selmer, this is Con Selmer, USA. Remember mouthpiece terminology: bore, table, chamber, baffle, facing curve, tip opening. And remember the one key thing here is what we want to talk about too is the basic concepts here. The mouthpiece can be quite complex in all reality, and we're just starting to learn about it right now. But let's learn about a few of the things first. In general, the more open the tip, the softer the reed. The longer the facing curve, the softer the reed. But a long facing curve and a closed tip, you can use a harder reed. So it all really depends. And the facing curve has implications on your reed selection too. If you have a long reed cut, basically, if your reed has a long cut on it, it may not fit well with a short facing curve mouthpiece, or vice versa. Taking a look here at my Vandoren page, let's look at the tip opening and facing curve length here and some general comments. This page I did a long time ago based upon some Vandoren information. The 5RV, for instance, start right there. And then we got the 5RV lyre, which has a larger tip and longer facing curve. And it says response, easy to control in all registers, excellent for students, symphonic and chamber music. Doesn't really say about any changes, but what happens here is with a longer facing curve and a longer opening, you end up normally with a little bit of softer reed. So it makes it a little bit easier to control and a little bit more responsive. If you use a harder reed, it's going to be responsive still, but the harder reed will also give it more depth of tone. This kind of reminds me of when I was studying Grover Washington Jr., who's a tenor sax player and alto sax, soprano sax. He used a really large tip mouthpiece and a number 4 reed, which isn't the way people normally go. But when I was working on that, using a harder and harder reed, using more air support, more air pressure, not necessarily more air, but more air support from the stomach, and I was able to play the 4, my tonality was really a deep, luscious sound, and more flexible and get it more airy too when needed. But the trouble is it created a lot of pressure in my head. I could feel the pressure in my head, and my eyeballs felt like they wanted to pop out. But the sound was enormous, and the volume was enormous of the tone. It was great sounding. But I went back to a soft reed because the air support for that was more than what I wanted to in daily playing. But it was a really good experiment, really good learning. Let's go on right back here now with a Vandoren 5JB, which is considered jazz mouthpiece, 1.47 opening and a 22.5 length of the facing curve. Very open tip, long facing, considered jazz mouthpiece. I use this mouthpiece a lot. It had a lot of air volume you could push through it. And I use this really well on a Selmer CT and also LeBlanc dynamic clarinets. And it's a really good mouthpiece when you need a lot of volume, a lot of dynamics too. Next one down, 11.1, 11.6. Those aren't very common. So we skip that. A B40. This is actually a wider tip. Now with a wider tip, you get more airflow getting channeled in. But it has on here is more resistance than a B45 and less bright than a B45. So this deals with the way the rollover baffle is. Once you learn more, with the B45, the rollover baffle is probably less in height. So it'd be less bright. Let's jump down to B45. Larger chamber, easier blowing the B40. So now we got a larger chamber, so it's easier to blow more, so you can get more volume in there. And the B40 said more resistant because you had to push more to get more air volume in there if you needed to. And it's good to compare mouthpiece descriptions like this when you come across it. Here we got a B45 lyre. It says the sound of the B40 and the comfort of the B45. Here we got a larger tip opening and longer facing curve. So this really probably comes down to the rollover baffle and how the rollover baffle helps accelerate air. Now there's a lot to the baffle itself when it goes down into the throat, and we'll get over that in a few minutes. B46 says good for a dance musician background. It has a medium opening and a shorter lay, so the facing curve here. So you'll get better response with the proper reed, of course, in that less of the reed has to vibrate, not long reeds. You got short reeds vibrating, so it has quicker response. So that's good. We can go on through here more and more, and you can read about this on my one page with the Vandoren page. But you can really start learning by comparing the description of these reeds. Now, keep in mind, you also have to learn how to play the mouthpiece properly. What I want to review real quickly on this page, as you can see, is the facing curve. If you do a blind test of playing multiple mouthpieces, you'll find out they'll sound similar. And that's usually because you aren't playing to the way the mouthpiece was designed. When I say how mouthpieces are designed, here I have an example of 5 mouthpieces. Woodwind K9 SML, Selmer Table HS Star, HS Double Star, and a Selmer C85 115. If we look up here, you can see how far this paper goes into the mouthpiece, which has a reed on there. So the longer the facing curve is really the point where the facing curve goes away from a flat surface is the neutral zone in essence. And if you play in the same place on every mouthpiece, then the facing curve really doesn't matter at that point. If you always play right here, no matter the facing curve, you're going to pinch the reed down, create a lower tip opening, and you're going to reduce something. If your bite is after the facing curve, the mouthpiece is going to be as open as possible, and the reed's going to be free to vibrate. If you basically bite down before the facing curve flattens up with the table, you're going to continually, like I said, modify the facing curve and play it the way that you play it. So if you do a blind test on mouthpieces, you may sound the same on most of them, and they may sound much worse than what you thought they would. You have to understand where the dynamics are. So if we start with a mouthpiece playing, we'll have an example in another video. If you play using just a little bit of the tip, you're going to sound really thin, and your sound's going to be not good at all. If you keep increasing, putting more and more mouthpiece in your mouth, and keep going, go past what you're normally used to, you're going to hear the sound, the tonal quality changes with the same air pressure. And that's the key thing is a lot of people, when they test mouthpieces, they don't take into account how the mouthpiece was designed. You have to understand the facing curve. And when you test mouthpieces, you have to understand the facing curve. You have to understand what you're starting with and how you want it to be. The player may play a certain way, and you want to make sure that you design and correct facing curves based upon the player's attributes and how they want it to react. On here, we have a Vandoren brochure. What's really important is down here, we get to see some examples of how they make mouthpieces. And this brochure is probably from 15, 20 years ago. So outside shaping, individual shaping. And they shave off some stuff here, as you can see. And what we get, they face the tip by hand. And the shaping of the table width is this one spinning cutting machine here. It's basically like a sander. Big metal piece. It may have texture on it, or they may put, like, as an example, sandpaper on it. I doubt it. It's diamond cut metal probably. So it's cutting the facing curve off, and not in a wheel basis, as I showed you before, not this way, but this way, spinning like this. Basically an orbital sander. So it's probably much more consistent. So back then it was done more by hand. In this case, in this example, a lot of things done by hand. Working on the baffle, working on the tip opening, the window and everything was done by hand at that time. There's another more recent magazine of theirs. I think I have these on my website. If you look around, you can find them. But this is a good PDF from Vandoren. Talks about mouthpieces, the parameters. I mean, the more you can learn about mouthpiece design, the more you'll understand it, and the more you can properly fix a mouthpiece for a player, or maybe even recommend a different one. If they really don't like the way a mouthpiece is, you may say, hey, this M13 will probably play the way you want it to, rather than me trying to fix a B45 to play like an M13. So the more you can learn about stuff and the way it affects sound, the more you can be more critical about your mouthpiece refacing. In this video, this is a modern technique for mouthpiece design, mouthpiece manufacturing. We'll look at it right now. What you see here is some are always use rubber rods. So when they get the rubber, even from 100 years ago, I remember the videos, they would have these long rods of rubber. In this case, this was really interesting. They just shove it in this one machine and out pops a mouthpiece. In actually two machines, out pops a mouthpiece. Yes, it is a saxophone mouthpiece, but about the same thing, manufacturing wise. Here you have a shaped spindle of a mouthpiece. Then they stick it in another machine that finishes the manufacturing of the mouthpiece. And that's about it. After this, they're just laying the, you can see the gold that they emboss into it, a gold strip. Now here is Ralph Morgan. I have one of Ralph Morgan's when he was still alive, one of his manufactured mouthpieces. I found this really interesting. I did not know how they made these mouthpieces because it looks like, I always thought, I never saw a seam in it. And these apparently done in a mold with two halves, put together, kind of partially finished. One of his tenor sax mouthpieces. It's a fantastic mouthpiece. Let's take a look at this video. So you notice that it says old World War II steam presses. Of course, you compare that to Selmer's using the rod rubber. What they're doing here is preparing a mold, and they're using multiple layers of rubber, which we'll see in a minute here. And then they press it. As you can see, the chambers here. Then they press it, put it in the oven, heat it. Over time, it all melts together. You get a example like this right from the mold. Looks like they had some injection down here too. And you can see in pulling the mouthpiece out, he has this metal thing to define the cavity inside of it. And it's 60% done. Fast forward a bit. They trim the seams. Looks like during production. Large ovens for curing the rubber. Then they clean it up more and more. Clean up the outer surface. They polish the outer surface. Then they start working on the insides, making sure the table's flat, and working on some of the curve too, and the table. One thing to keep in mind here is as you flatten a table, you have to make sure, because as it becomes flat, it's going to create this edge to the facing curve. You always have to make sure that you curve that edge too. And if you notice his motion, it wasn't just flat straight back. It's going like this, making sure that little edge isn't there, which you can do during or afterwards. He just had so much experience doing it, he just did it during. Before after pictures, facing cut. Shaping the baffle area. Then later polishing it all up. And that's hand fixing a mouthpiece. A lot of work when you deal with the insides, not just the basics. Of course, the more we learn to do things with the mouthpiece. Our first example is just going to be simple fixing the mouthpiece curve and table in the next episode. Here's another mouthpiece maker. Saxophone once again. This is really interesting. This is really hand making a mouthpiece. The old way with modern techniques and equipment. It's quite amazing the amount of time he puts into each and every mouthpiece. Yes, he's doing the facing curve by hand, both hands working on the basics of the curve and the cut of the tip. One hand left and right. Doing the beak. And I'll put links to all these videos in the description. One of my favorite clarinets, as I mentioned before with LeBlanc, has been the Opus Concerto model. Here, Tom Ridinghauer, who actually helped design or did design the concerto, talks about mouthpiece and everything about the mouthpieces. There's a lot of people who don't understand the mouthpiece is such a complex thing because the mouthpiece is so complex. It identifies the pitch, color, shape of the tonal qualities and also intonation and your ability of dynamics. And of course, it affects stability, response, and resistance. So everything you do can affect the way the instrument responds, the way the player responds to the mouthpiece, and everything else. So you got to understand all these things as you work on a mouthpiece. Simple refacing of a mouthpiece, make sure the table is flat and the facing curve is perfect. If done right, you remove as minimal amount of material as possible so you don't affect anything else. Because the more material you remove from the facing curve, the more you can affect the actual height of the baffle from the side rails, which would affect the amount of air volume. But briefly, we'll listen to Tom Ridinghauer here. And that's important there, as you'll learn. I'll have links to these videos, but the mouthpiece is the first thing, of course, that affects pitch other than the player. And the baffle design and the bore of the mouthpiece all affect pitch and intonation. So the design is really important, and being able to reproduce it every single time is important. As I mentioned, just the table and facing curve is just the beginning of the complexities of the mouthpiece. Well, I'm going to put in the description links to those videos and other videos I think are very important so you can learn about mouthpiece design and the way they affect everything about the instrument. Anyways, we'll continue on in the next episode, more about and actually get down to flattening the table and working on the facing curve a little bit of a couple of example mouthpieces. Anyways, I want to thank you for listening to my ramblings. Any questions or comments, put it down below. Don't forget to give a thumbs up, like, subscribe, and share. Because you gotta love the knowledge, gotta love life, you gotta love clarinets and mouthpieces. So we'll see you next time.